Hello everyone, this is Dr. Amit Kumar Pandey. I am going to discuss today SJF CPU scheduling algorithm, which is the important CPU scheduling algorithm in operating system. In operating system, there are several processes and every process want to get executed then. So there should be some strategy or a policy to execute all the processes in some specific manner so that there will not be any starvation. So let us see what is inside SJF one by one. The basic of SJF. In SJF CPU scheduling, out of all the available processes, the process having smallest bus time will get the CPU first. And the second smallest and the large process will get the CPU in the last. Means if there are three processes, then in SJF we sort all the three processes according to their bus time, and the process which have least or smallest bus time will get executed first. Then the second process having the second smallest bus time will get executed, and in the last, the process which have the largest CPU bus time will get executed. Now, if arrival time of more than one process are same, then process with smallest bus time will get the CPU. Okay. If there are number of processes or two or three processes which arrives at the same time, in this also the process which have least burst time or smallest burst time will get executed first. If number of processes or more than one process arrive at the same time and also have the same burst time, then what to do? In this scene, the process which have least process ID will get executed first. Okay. Types of SJF, there are two types of SJF. First is non-preemptive SJF, simply known as SJF CPU scheduling algorithm or shortest job first CPU scheduling algorithm. And second is second is preemptive SJF, which is known as SRTF also, means shortest remaining time first CPU scheduling algorithm. So in non-preemptive SJF, this is a simple SJF. There is no preemption at all. In preemptive SJF, process will be preempted according to their remaining burst time to time. So in this video lecture, we will cover non-preemptive SJF, and for SRTF, we have another lecture. Advantages of SJF. SJF provides less average waiting time than FCFS CPU scheduling algorithm often, and SJF provides less average turnaround time also in comparison to FCFS. Disadvantages of SJF are practically it is very tough and most probably not to be implemented because first time of the processes cannot be known in advance. Second, it can also lead to starvation for those processes who have larger burst time, and priorities cannot be set for the processes in this algorithm, and processes with largest burst time have poor response time. So what is the algorithm? Let's check by a numerical. So here we take an example for simple SJF, means non-preemptive SJF. So let us see. Here we take some processes and their respective burst time. In this numerical, I do not take arrival time. So this is a very basic numerical for SJF. This is non-preemptive SJF. It's P1, P2, and P3. And respective bus time for P1, suppose this is 100. First we see with larger process, the first for P2, this is 20, and for P3, this is 10. So what is the logic of SJF? The process who have least bus time or smallest bus time get executed first. So in this scene, we have to sort all the process according to their bus time in ascending order. So sequence will be first P3 will get executed, then P2 will get executed, then P1 will get executed. Okay, we here prepare a Gantt chart. 1, 2, 3. First P3 will get executed, second P2 will get executed, and in the last P1 will get executed starting from 0 because there is no arrival time. Arrival time is not given. So we assume all the processes are available at the beginning. है ना? When CPU going to start execution of processes. So from 0, P3 will take total time 100. Sorry, P3 will take total time 10 because this is non-preemptive. P3 is finished now. Again P2. What is the worst time of P2? This is 20. So here total time will be 30. Now P2 get executed. Now this is turn of P1. So bus time of P1 is 100, so it will be 130. Now P1 also get executed. Asking are same in every numerical. They demand for AWT. AWT, what is AWT? Average waiting time. Okay, again, there is some technical mistake, I think so. So here are process and their respective bus time. P1, P2, and P3, and their respective bus time. P1 for P1, this is 100. For P2, this is 20, and for P3, this is 10. Here we make a Gantt chart for that. P1, P2, P3. Starting from 0, sequence will be first number of P3. P3 have least bus time, so we'll get execute first. Then P2 will get executed, and then in the last P1. So P3 total time taken by P3 for execution is 10. So here I write 10. Then P2 will take 20 unit of time, so total time will be 30. And P1 will take 100 unit time, so total time will be 130. So asking is same for every numerical, which is AWT. What is AWT? AWT is average waiting time and 80/80. 80/80 is average turnaround time. Okay. So according to Gantt chart, individual waiting time for P1, for P2, and for P3. So for P1 this is 30, for P2 this is 10, for P3 this is 0. Because here arrival time is not given, so we assume that when CPU start execution, all the processes are available for their execution. So we can assume arrival time for all processes is 0. So waiting time for P1 is 30, P2 for 10, and for P3 is 0. Now we want to calculate turnaround time. Turn around time for all the processes. So this will be for P1, waiting time 30 plus burst time of P1 is 100. So this will be 130. For P2, this will be 10 plus burst time of P2, which is 20. This will be 0, 30. And for P3, the turnaround time will be waiting time, which is 0, plus burst time of P3 is 10. So this will be 10. Now, asking was average waiting time and average turnaround time. When when we get individual waiting time of every process, then what will be the average waiting time? Average waiting time will be summation of all these numbers, means individual waiting time 30 plus 10 plus 0 divided by number of process, which is 3. This will be 40 divided by 3. And what will be the 80-80? 80-80 will be addition of all the individual turnaround time, which will be 130 plus 30, 160 plus 10, 170. This will be 170 divided by number of processes. So here we take an example in which arrival time is not given, not mentioned. There are only process and their respective bus time, and we saw how we calculate the average waiting time and average turnaround time for that. Okay. So now take another example. In this example, we will take arrival time. So again, here are number of processes, their respective burst time and their respective arrival time also. So here we take three processes P1, P2 and P3. Their respective bus time same 100, 20, 10 and arrival time is 0, then 20 and 10. So here we have some precautions. Precaution is that very carefully watch out the arrival sequence, because this will tell you how many number of processes are available for execution. Then we have to sort all the available processes according to their burst time. Okay, na? As this is simple SJF, so preemption will not occur. Okay, na? Preemption will not occur in this scene because this is non-preemptive SJF, simple SJF. So we will execute all the process one by one. See how. Total process are three, so we divide it into three parts: P1, P2, sorry, three part. Now we check the sequence which will get executed first. So please don't consider P1, P2 now. We will update that. So at the time 0, there is only one process inside the system. So when we have only one process, then there is no other process for comparison. So we consider P1 as the smallest. Okay. So at the time 0, we have P1. CPU have P1. So CPU will get execute a P1. As this is simple SJF, means not preemptive SJF. So preemption is not done. So P1 will get executed completely. So what is the bus time of P1? This is 100. So it will take total 100 unit time for its execution. Now P1 is finished. When P1 is finished, then total time here is 100 unit time. Meanwhile, P2, which comes at after 20 unit time, is also arrived, and P3, which comes after 10 unit time, is also arrived. So there are two processes available for execution, P2 and P3. When two processes are available, then we have to compare the bus time of both processes to find out which one is the shortest. So for in P2 and P3, which one is shortest? This is P3 with 10 unit bus time. So we will execute P3. So here total time will be 110 because P3 have bus time 10 unit time. Now P3 executed. Now we will execute, CPU will execute P2. What is the bus time of P2? This is 20. So total time taken by the CPU to execute all the process is 130 unit time. Asking is same. Find out AWT and ATAT. ATAT. So for AWT or ATAT, we have to calculate individual waiting time. So for this Gantt chart, we can see for this chart, we can see waiting time for P1, waiting time for P2, and waiting time for P3. So from Gantt chart, this is 0 for P1 and 110 for P2 and 100 for P3. This will correct if all the process arrives at 0 time, but scene is differ. At 0th time, only P1 was available, P2 and P3 comes after. So we have to minus arrival time of individual process. Arrival time for P1 is 0, so 0 minus 0 equals to 0. For P2, arrival time is 20. So 120, 110 minus 20, it will be 90. For P3, arrival time is 10. So 100 minus 10 will be 90. If we talk about average waiting time, then this will be AWT will be 0 plus 90 plus 90 divided by 3. 180 divided by 3 equals to 60 unit time. If we talk about TAT, as we calculate in previous example, TAT will be for P1, waiting time of P1, which is 0, plus burst time of P1 is 100. So this will be 100. For P2, TAT will be waiting time of P2 is 90 plus burst time of P2 is 20. This will be 110. And for P3, this will be 90, which is waiting time for P3 plus burst time of P3 is 10. So this will be 100. If we talk about average turnaround time, 80-80, then 80-80 will be summation of all the values and divided by number of process, which is, this will be 310 divided by 3 unit time. Okay, I think this is clear to all of you. Now we will see another example. Here are 5 processes P1, P2, P3, P4, P5 with their respective arrival time and burst time. So in non-preemptive SJF, which process will get executed first? So according to arrival time, P4 is available for execution at 0 time. So P4 will get executed first and burst time is 6. So when P4 will finish 3, 1, 4, 2, all the process, all the remaining process P1, P2, P3, P5, all will arrive. So P4 will execute completely. Then we have short P1, P2, P3, and P5 according to their burst time. So after P4, P1 will get executed on second number, then P3 on third number, then P5 on fourth number, then P2 on fifth number. Let us check one by one. So P4, as this is the only process which is available at 0 time, then P1, P3, P5, P2. So we prepare this Gantt chart, and according to this Gantt chart, we will calculate turnaround time plus waiting time. So here we use exit time. We can see exit time. So this is the exit time for P4, 6. This is the exit time for P1, 7. This is the exit time for P3, 9. For P5 and for P2. So first we write exit time from Gantt chart. Then TAT, calculate the TAT. What is TAT? TAT equals to exit time of individual process minus arrival time of individual process. When we get TAT for individual process, then we will calculate waiting time for that process, which will be TAT minus burst time. In this manner, we will get individual TAT and WT for particular process. We will apply same logic to find out individual TAT and WT for all the processes. Now, our task is easier. We have to calculate average waiting time and average turnaround time. So for average turnaround time, add all the values and divide by number of processes, which is 5 here. And for average waiting time, add all the values, all the waiting time, individual waiting time, and divide by the number of processes, which is 5 here. So here, in this way, we calculate average turnaround time and average waiting time. I hope this lecture is beneficial for you, benefited you. Logics are clear for SJF, preemptive SJF, non-preemptive SJF. Thank you for being with me. Here are some references which I have used in my lecture. Thank you all everyone.